believe we are ready for the bottom of page 340. We finished with number 5, I hope, right? And this is kind of a in between number 5 and 6 section. They're asking us to do a little more practice as we translate between definite integrals and Riemann sums. Now, first of all, it says use your calculator to evaluate the definite integral. Your calculator has an option. If it's a definite integral means it has the boundaries, that you can plug it into the calculator. Let me guess, you don't want me to tell you where to go, you want to find it?
Is it not the same thing?
Is it the same program we used yesterday or no?
Yesterday we were doing a summation.
Oh.
You're looking for the integral symbol today.
This is,
wait, what's the? Oh, it's that.
You're looking for an integral,
Alpha F24.
Yeah.
Oh, found it.
and it's also in the math menu something.
I couldn't find it.
You can't?
Oh, it's number 9.
Finnet.
Yeah. Math menu number 9, where it's finite. Or, as you said, alpha F2, number 4. And notice it brings up an integral. Real easy. You type it in. So if you need a note to yourself, in the math menu, it's number 9. Or in the alpha F2 menu, it's number, I forget, 4? Okay, you plug this in and you got 2.5. Really, that is such an easy integral to do by hand, but we're not there yet, so. Okay. B, ask us to find the corresponding Riemann sum for this definite integral. Now, the width, delta x equals. Well, what do we know about delta x? How do we find delta x? Let me ask it that way.
B minus A divided by something in.
Okay, so what do we know?
B is 2. A is 1.
A is 1. B is 2. What's n represent?
Here. So 1.
Total number.
Okay, it's our number of rectangles, partitions, I think they use the word sometimes. Okay, our number of intervals. So does it say anything about that? No, so we're going to use n as n, which means delta x is 1 over n. So this is your width. X of k. We had a formula yesterday, right? How do we find x of k?
A plus delta x times A.
So in that case, what are we going to have? Just filling in your formula there, it's 1 plus 1 over n times k. Which, not that you couldn't write it as k over n, but you don't necessarily. I don't know, sometimes you do, sometimes you don't. Okay, and then, so if x of k is 1 plus 1 over n times k, the height, f of x sub k, is going to be what? I guess I should back up and ask, what is f of x?
X plus 1.
Uh-huh. Yep. F of x is indeed x plus 1.
So it's plus
I mean, if I write it, that's kind of the long way. That it's 1 plus 1 over nk plus 1. Technically, that could be cleaned up, yes? What does that clean up to be?
Plus 1 over n.
Yep. Okay. 2 plus... Yeah. Instead of writing it as 1 over nk there, I did actually change to k over n at that point.
Does it?
No, not necessarily. Okay, so you could, you know, I'll put it there just so we have it. You could think of it as k over n. Okay. Again, if you leave it as 1 over nk, that's fine. And here's the reason, I guess. Up until this point, it was very separated. We could pull an a value out. We could, you know, now that we've kind of combined it, it's a little harder to pull an a value out and all of that, but that's all right, you know. Okay. Write the corresponding Riemann sum. So we're going from the integral to the limit summation notation. Okay, so officially we want to say, I don't know if I remembered to put this on there yesterday or not, the limit as n approaches infinity. That summation sign that I don't draw very well. And you guys can take over from here.
No.
Yep. K equals 1 to what?
No.
No. What normally goes on top? Not 2.
2.5.
No. It's not the other end of the interval.
It's not.
How many? Oh, it's n.
It's how many partitions there are. And in this case, what are we using for n? N. So, in other words, when we don't know, okay, and that's what, with an integral, you don't, it's not a set number of partitions. It's an infinite number of partitions. Okay, and then what do I do?
Put in the plug in
F of X.
F of x sub k and delta x. And that is your official Riemann sum. D asks us to evaluate the limit of your Riemann sum on a calculator. Everything I have found, I don't think we can do this on our calculator because this is the summation from 1 to n. We don't know n. It's the limit as n approaches infinity. You can't enter a 1 to infinity on your calculator. You can't do a limit on your calculator. So I don't think we can do this. She likes to use the TI Inspire, which is a different, it's kind of a higher level calculator, and you can do it on the TI Inspire. But I don't think you can do it on your TI 84s. But what's the answer going to be? If we've done this correctly, the answer should be 2.5. Because what we've done is we've taken this integral and rewritten it as a Riemann sum. So the answer would be 2.5. It's just that we can't do that on the calculator there. Okay? And only because we don't have the right calculator. Okay? Okay. That probably would have gone a little bit smoother if we'd done it yesterday, right after we'd done the other stuff. But I'm making you dig back from 24 hours ago, or 23 hours ago. Okay, next page. Okay. We're going to kind of practice more with this. In each of the following problems, translate the definite integral into a Riemann sum. Be sure to check that both forms yield the same numeric values, which, again, we can do the integral on the calculator, but we don't have a way to do the Riemann sum. So, our goal is to write the Riemann sum. What can you tell me? Basically, we're doing the same thing we did in the last problem. We just don't have the steps walking us through it.
B minus A over N.
Okay, b minus a over n is going to help us find our delta x. And what are a and b and n? A is 2. B is 4. What's n? It's n. So what's delta x going to be? Yeah. It's going to be the 4 minus 2 over n, or in other words, 2 over n. We need height. So I always start off by finding x of k, and then I'll plug it in. Do you remember the formula for that?
A plus delta x.
A times delta plus delta x times k. That formula I'm going to keep writing out because it's just, I need to make sure we remember it. So what does that make x of k? Two plus 2 over n times k, right?
Yeah.
Now, on mine, I didn't actually find f of x sub k right here. I just skipped to writing the Riemann sum. I don't know why, but wouldn't hurt to look at this. F of x sub k. What are we going to?
Plus 2k over N.
No, that's what just x sub k is.
Or f of x is x squared minus 1.
Our f of x, did you say the 3? Is 3x squared minus 1. So, what's that mean we're doing? 3 times
2 plus 2 k squared.
Not pretty, but that's all right. We don't have to do anything else with it. Okay? So I totally agree, not pretty, but we'll survive. Okay, so we have all the information. Write your Riemann sum. So officially it's the limit as n approaches infinity, because I don't have, it's not a definite, or it's, I don't have n. The summation from k equals 1 to n of f of x sub k notice I'm putting that, because I have parentheses around the x sub k, I use brackets around the whole big thing. There's my f of x sub k, and then multiplying it by delta x, which is the 2 over n. And you can write it just with a multiplication dot. You can put it in parentheses. You know, there's flexibility there.
How come it was k equals 1 instead of k equals 2? Does A not go on bottom?
A is not on bottom. Remember, this is basically how many partitions you have. Okay? This is how many partitions we have. No, I don't have yesterday's notes, right? I would go back to one of those. But, and if you remember, like the traditional right Riemann sum always starts at 1, and then it's n on top, which is how many rectangles there are. When we're doing an infinite scenario here, we just have it as 1 to n. Okay. Just the same, we could say 0 to n minus 1, but traditionally we do 1 to n. Okay? Okay. Ready to go? You got it? Talk me through B.
So delta x is 2 over n. Negative.
No, it is 2.
What?
B minus A.
Oh, yeah.
I know, I had to stop and think too.
Wait. What?
So our formula is
Oh,
B.
0 minus negative 2.
Right. Yeah, so it's B minus A, so 0 minus negative 2 over n, which does make it 2 over n. I guess I could just check my answer key, yeah. X sub k, A times delta, or plus delta x times k, so x sub k, negative 2 plus 2 over n times k, or 2k over n if you prefer. Now, oh, I skipped the other part of that. Oh well, we'll do it at the end. I skipped the value box, but that's just using your calculator. Do you want me to go ahead and write out f of x sub k? Or you just want to jump to the limit? We do f of x sub k. What's going on here? X plus 3 quantity squared. So negative 2 plus 2n over k. So there's x plus 3 quantity squared. Could you clean that up a little bit?
Yeah.
Yeah.
Yeah, you can. It makes it confusing if you're trying to undo this and go back the other way, but it's cleaner if you're just trying to do the operation. So this can also be written as 1 plus the 2k over n quantity squared. Okay. The limit. What am I doing? There we go. As n approaches infinity of the summation from what to what? K equals 1 to n. Height times the width. So the 1 plus 2k over n quantity squared times 2 over n. I know it seems repetitive, however, you kind of have to think about it. So a little extra practice doesn't hurt because maybe it'll, stick itself in your brains. Should we pause for a moment here? The value, it's wanting the value. And it said to be sure to check that both forms yield the same numeric values. Well, can I do this summation on my calculator? No, because we have n and we don't know n. It's n approaches infinity. However, could you put the integral on your calculator? Yes. You want me to tell you the values, or do you just want to put, or do you want to put them in? We're over it? Okay. So, first one worked out to be 54, and that would be if you did, on all of these, it's going to be if you did the integral, but the limit notation would be the same. What was this one? This one is 26 thirds, or 8.6 repeating. Okay. Okay, one more, and then we've got to go learn how to go the other way. I think it's harder to go the other way, so. You got this one? A and B? A and B are 0 and pi. Delta x? Pi over n. X sub k? A plus delta x times k. Or, in other words, pi over n times k, since a is 0. Or you could say pi k over n. And if we do f of x sub k, where are we putting x sub k into?
Sin x.
Sine x. So that means it's going to be the sine of pi k over n. Because right there is my f of x. So the limit as n approaches infinity of the summation from k equals 1 to n of sine pi k over n times pi over n. And if you take the moment to plug it into your calculator, you get 2. At least that's what I've written down you get. We're going to trust it. Okay, guys. Now we got to work backwards. Okay? So on 7, we're going to see about working backwards. Each of the following translate the Riemann sum into a definite integral. Check that both forms give the same result. Again, we can only check that one form. So the limit as n approaches infinity, summation k equals 1 to n of 5 times 5k over n minus 2 minus 1 times 5 over n. What I'm going to say is start pulling out any information you can give me.
Delta x is 5 over n.
Okay, you with them? What did you say?
F of x is 5x minus 1.
Do you guys see that? I agree. And really, I would have identified x of k first, but that's all right. You guys are seeing that it's 5 times this ugly thing minus 1, yes? So what it appears is that if you take that out, f of x is going to be 5x minus 1. Okay? Continue.
X of k would be negative 2 plus 5n times k.
Okay. So x of k, he reversed it, and I get it. It's negative 2 plus 5 over n times k. I like it. So that right there is your x sub k. And he's doing that because what do we know? We know x of k is a plus delta x times k. Well, first of all, does that match up for delta x? That's a good check because sometimes they do wonky stuff. Okay?
So a is 3.
Well, officially I'm going to state that a is negative 2. Obviously, you guys figured that out. What do you think b is?
3.
Yeah. And what do you have to use to figure that out? Yeah. We know that delta x is b minus a over n, don't we? So at that point, you're knowing that b minus a is equal to 5, but b or a is negative 2, so b plus 2 is 5, and b is 3. I know, you guys probably did that in your head, but there's some work to write down. Okay, good. Our job is to write this as an integral. Here's my help.
Negative 2. Fx minus 1.
Yes.
There you go. And you could plug it in the calculator, right? So there's the answer. If you plug it into the calculator, I have written down that you get 7.5. You can check that if you want. Okay? So, and I will say, we're looking at the easier versions here, right? Sometimes you have to do some manipulation, but sometimes you have to do some really difficult manipulation too. Okay, ready for B?
Yeah.
Okay, what are you going to tell me?
Delta x is 2 over 8.
I'll take it. Okay. You guys are all just writing stuff down, aren't you? Augie's staring at me, but everyone else is just doing their own thing, writing stuff down.
X is 3x plus 4.
Okay.
X of k is negative 2 plus 2 over n times k.
And I like how you guys are kind of pulling that apart and putting it in the form you're used to. Which, keep in mind that we know x sub k to be that a plus delta x times k. Okay, okay.
A equals negative 2.
Okay.
B equals 0.
Sounds like he's asking a question.
I think so.
Okay. So we know that b minus a is equal to 2 according to our delta x. We just found a to be negative 2, so b plus 2 equals 2. So yes, I agree. B is 0. Okay. Write your integral.
Negative 2 on bottom, 0 on top. And then parentheses 3x plus 4 dx.
And my note says it equals 2. Okay. You got C?
F of x equals, sorry.
Okay.
I think A has to be like 6 to the negative first or something. Maybe not. Just
It would be,
You guys are jumping around a different order on this one.
because the
Because it's not as. How did I.
well, maybe not. Somehow something goes through to my head.
I'm debating how I want to. So. Okay, let's talk about delta x. Where are you seeing delta x?
pi over 6.
Okay, and that's still true. Okay, that is our delta x. Now, with that in mind, pi over 6n, what are we used to seeing? Something over n, right? So think about it this way, that if we separate that n, this is pi over 6 times
1/6.
1 over n.
That's fine.
Okay? Can you agree with that step I've written? Okay. And keep in mind, if, for instance, okay, side note, when we had 2 over n, wasn't that 2 times 1 over n, if you will? Okay. So technically, we could say this is pi over 6 over n, is what we could say. I mean, I think I just have it written as that in my piece. Okay. So just realizing you have to separate that in. Remember, pi is a number, right? So pi goes with the 6. It's a number. And that would, then make it something divided by n, essentially. Okay. What do you have going on with x sub k?
Pi is 6. Wait.
A is 0.
Could A just be like 0 or 1 or something?
Does that work for you? Because A can be 0. And keep in mind, it won't necessarily be there, right? They're not going to probably waste writing that 0 in. That's something you have to be able to pull out.
B is 6. No. Yeah.
So B minus A is pi over 6. So B minus 0 is pi over 6. And yes, indeed, B is pi over 6. Okay. And I think we have all the information we need, don't we? Yeah. Okay. It gets tougher, doesn't it? First two are breaking you in, it gets tougher. We're skipping. I'm going to stop there. Because I guess we could look at A if we really wanted to. B, to me, is a BC one, because there's a sequence in there, and that's more Calc BC, and we're AB. So,
So that will be on homework test.
definitely wouldn't be on test. I hope it's not in homework. I don't remember what's in homework, of course, but so. I think
1 page.
it is.
No,
It's like 1 page.
Yeah. So, hey, you could use this work time
I don't know.
and make some progress on it.
Maybe I'll do 1 problem.
I want you to check the weapon.
Oh my goodness.
If you keep checking it, then it's not